Welcome to Study Loop.
Okay, so our question says, a particle starts from the origin at time t equals 0 with an initial velocity of 5.0 meters per second along the positive x-axis. If the acceleration is minus 3.0 I hat plus 4.5 j hat meters per second squared, determine the velocity and position of the particle at the moment it reaches the maximum x coordinate. Okay, so since the acceleration vector is constant, equation 3-13a for finding the velocity of a constant acceleration and 3-13b for finding the position with a constant acceleration are applicable. And the particle is going to reach its maximum x coordinate when the x velocity is 0. So v of x is going to be maximum when x is equal to 0. The maximum coordinate is going to be when v of x is equal to 0. And I also wrote what we were given, which was that the initial velocity is 5.0 meters per second in the positive x direction, which is I hat. And the initial position is the origin, which is just 0 for the x and y coordinates here. Okay, and then another thing we're also given is the acceleration. So I can go ahead and write that out. And the acceleration is equal to minus 3.0 minus 3.0 in the I hat direction plus 4.5 in the j hat direction. And of course, since it's acceleration, that's going to be meters per square second. Okay. So first thing we can do is we're going to use the equation 3-13a to find the velocity. With the constant acceleration is equal to v naught plus the acceleration times the time. Okay, well, we know what v naught is and we know the acceleration, but we don't know the time. We need to figure out when t max. But like I said, t is maximum, so we'll write t is max for m, tm at v of x is equal to 0. So if we plug that in and we solve here, so we're using v of x, right? So in the v of x direction, we only consider things that are in the I hat. So we have 5.0 from v of 0 minus, right, 3.0 t from a of x times t. And these are all in meters per second, right? Well, that t, since at v of x is max, when v of x is max, that's equal to 0, this is t max. So we can solve for t and calculate t max. So if we solve for t, v of x is 0, and this is equal to minus 5.0 divided by minus 3.0. And that's in seconds. If you calculate this out, you get 1.67 seconds. That's the maximum. That's t max when v of x is maximum. Okay? Now we can plug this time back into our original equation. I just put a little star next to it. So we're going to have 5.0 in the I hat direction, right? Minus, this is going to be minus, this is a plus, minus 3.0 plus, I hat, we need to indicate directionality, plus 4.5 j hat times 1.67 seconds. Right? And if you carry this out, you will find that the I hats cancel, and you're left with 7.5. And this is meters per second because it's velocity in the j hat direction. Okay, go ahead and box that in. Okay, next we want to find the position at this when v of x is maximum. We want to find the position. Well, we can do that by using the other equation, which is r is equal to r naught plus v naught times the time plus 1/2 the acceleration times the time squared times t squared. Okay, so r naught is 0, so we have 0 there. So the first thing we're going to have is for v naught, we have 5.0, and that's in the I hat direction, right? And then you're going to multiply that by t, but t is 1.67, so 1.67, okay, plus 1/2 multiplied by a, once again, which is minus 3.0 I hat, plus 4.5 j hat, okay, and then that is going to be multiplied by the square of t, which is 1.67. Time was 1.67 for t max squared. Okay, if you carry this out, you find that, well, and if you actually, we can go ahead and put parentheses around this entire thing. The units on this, of course, since it's meters, or its distances are going to be meters, right? So you find that this has a value of 4.2 in the I hat direction, plus 6.3 in the j hat direction, and of course the units of this is meters. Let's go ahead and box that in as our solution to the second part.